Okay, so looking at your graphs and everything, everything looked okay. But what worries me is, I'll zoom in a tiny bit. What worried me, maybe I won't, if my computer will cooperate, or it would zoom in. Okay, so maybe I won't zoom in. What what I'm worried about is that point right there, 8, 8. I'm not quite sure where that came from. I think what you meant to be doing was using the intercept method for graphing. So this first equation, the green equation, so since you did it in green, I'll do it in green as well. This first green equation should be coming from the idea of x plus y is equal to 8, and saying, okay, if I'm going to graph this thing, where would my x and y intercept be? So that means I'm going to have something of that form. I plug in 0, I get out y. I plug in 0, I get out x. So starting here, when I substitute in 0 for x, I would end up with 0 plus y equals 8, which just leaves me with y equals 8. So right there I have the point 0, 8. Similarly, here this is saying substitute 0 for y, so that would leave me with x plus 0 equals 8, which leaves me with the point of x equals 8. So therefore I have an x-intercept of 0, 8, a y-intercept of 0, 8. So now when I go look at your graph, it looks perfect. You have your intercept going through both of those values. Now you connect the dots, that looks perfect. So let me do something real fast. Let me pause the video. Okay, I couldn't get it to look nice because of the graph paper. I was trying to black out all your shading so that way I could see it easier, but I'll just do it on my own little graph down here. So you see I've just kind of mimicked what you did, gave us the intercepts of 0, 8, 8, 0, and now shading. I use a method called test points, and the idea for a test point, not tests, test, singular, a test point, there we go. And the idea of a test point is quite simple. You pick any point that is not on your line and you substitute it into the original equation to see if it gives you a true or a false statement. So our original statement was greater than or equal to. So what I'm going to do is take the value 0, 0, sub it in for x and y, and I ask myself, is that a true statement? And the answer is no, that is false, because 0 plus 0 is not greater than or equal to 8. So therefore, that point 0, 0 that I just tested gives me a false statement. So I don't shade on this side, I shade on the other side. And you'll notice how I do my graphing. I don't shade like you did. I don't shade everything. I just kind of make the line fuzzy. So that way, whoops, let's undo that. I just make the line fuzzy so that way I don't have too much going on the page, just little bits. So there's our first line. Now I'm going to erase all this work. I'm going to bring up our second line. So we do this the exact same way. And so here you had 10, 10. So I think again it's similar. We're going to get our intercepts, which means we're going to get 0, and 0, so aka the y-intercept and the x-intercept. So when I plug in 0 for x, substitute in 0 for x, I end up getting y equals 10. When I substitute in 0 for y, I end up getting x equals 10. So now those values would be somewhere out here. Let me extend this line just a tiny bit. Oops, there we go. So that gives me a 10. So now I connect the dots. Okay, so I've connected the dots as best as I could. I have a little trail, let's see if I can get rid of that without getting rid of the line. Oh, nope, didn't happen. Okay, so now we've got our line, not perfect, but close enough. So now shading again, I'm going to use my same test point, and as long as this point is not on the graph, I use it every single time, 0, 0. So now when I substitute that in, I get 0 plus 0 is less than or equal to 10. That is a true statement. So that means when this point down here, that's 0, 0, since that is true, that means this whole side of the equation is true, so it's shading down. Okay, so now that's equation 2. Continue on equation 3, onto equation 3. So here we go, our x and y intercept, 0, 0. So when I substitute in 0 for x, I'm going to end up getting out negative 8 for y. When I substitute in 0 for y, I'm going to end up getting out 8 for x, and now I'm going to plot those points and connect the dots. Okay, so we have negative 8 and 8, and now on for the shading. So test point again of 0, 0 for our test point, and when we substitute that in, let me scroll back up, when we substitute that back in, we get 0 minus 0 is less than or equal to 8. This is true because 0 is less than 8. So therefore, this point of 0 this point of 0, 0, we're going to shade that side of the line. So you can already see where these are starting to overlap. They're sandwiched somewhere between the green and the blue, so there's no need for me to shade out here. So I'm not going to make my picture, whoops, I'm not going to make my picture look more confusing than it needs to be. I'm just going to shade where the overlap is. But if you wanted to, you could shade this whole line. Okay, so then on to the fourth line. Okay, so this one is x minus y is greater than or equal to -8. So when I'm finding my intercepts, once again, we're going to say 0, blank, blank, 0, substitute in. So when I put in 0 for x, I end up getting -y, which give me a +8. And when I put in 0 for y, I end up getting a -8. And so therefore, our x-intercept is somewhere here. Whoops, excuse me. Our x-intercept here isn't somewhere at -8. The y-intercept is somewhere at +8. So we connect the dots. And that's going to give us, okay, that's totally not on, but it's going to be really hard for me to move with the pen. Anyway, you get the idea. This one, it's close enough. Just imagine shifting it up a little bit. Okay, it was just bothering me. There we go. So now, let's go ahead and shade. So our test point, once again, it's not going through it, so I'm going to always use 0, 0. So test point of 0, 0. When I substitute that in, that's going to give me 0 minus 0 is greater than or equal to -8. And again, that is a true statement. So this point 0, 0 is true, so I'm going to shade this direction. So therefore, now what I'm doing is I've got all 4 of my equations graphed. So now I'm looking at this where they all overlap. And you can see it's this wonderful little box right inside here. So to me, it looked like you had the right idea for everything. It just looked like your shading was off. Your graph looked good. Just not sure about the shading. And then I wasn't quite sure what these points meant, if you were literally thinking those were your intersection points. So now what we have to do is find each of these intersections. So I'm going to go ahead and label them A, B, C, and D. So we'll call this one down here A, B, C, and D. So now we need to find each of those. Now A is relatively easy because that was right at an intercept. So we already know what A is because that was our method for solving. A was 0, 8. B is going to be a little more interesting. C is going to be a little more interesting. But we also know what D is because that's another one of our intercepts, 8, 0. So now, how do we find B and C? Well, this is where you did awesome, which was you made it very clear which equation belonged to which graph. So what I'm looking for here for B is the purple with the blue. So where purple and blue intersect, well, that's just the blue equation, which is x plus y. Now, because we want the intersection, we're not talking about the shaded part, we're talking about just the line. So that's the equals to part. So, I apologize. The blue was x plus y equals 10, and the purple is x minus y equals 8. So now we can solve this. The idea here that you're supposed to catch on to is that how do we solve this? We're not going to do intersection on our calculator. That is probably the worst method you could possibly use. It takes so much longer to type this stuff in the calculator, and if it comes out to be a decimal or something imperfect, then you can't even use it anyway. So let's use methods that we've learned in the class. There's a reason we went through chapter 3, and the reason is this is just a substitution problem, or an elimination problem, or a reduced echelon form Gauss-Jordan type problem. So pick whichever one you see to use for this situation. I see this as to me, it's an elimination technique because I've got a positive y, I've got a negative y. So if I just add these two equations together, I end up getting 2x equals 18, which means x equals 9. Now I can go back, I can go in back sub to solve for y. And as we should know from the previous sections, it doesn't matter which one we sub into, so I'll just go into the first equation. So that would give me 9 plus y equals 10, which would give me y equals 1. So therefore, I know my point B is at the point 9, 1. So now we just need to do C. We do it the exact same way. You just say which two equations are intersecting to give me that point. So I see it's my blue and my red. So my blue is the x plus y equals 10. And the red, I forgot what it was already. X minus y equals 8. Excuse me, did I get the right ones? Oh, silly me. My color blindness is getting me here. So this is why I usually label my equations A, B, C, D instead of colors. But that's okay. So what we're going to do here, all I did here is I accidentally switched them. I did this. If you notice, the x plus y equals 10. I apologize about that. You're probably sitting there wondering, what were you talking about? X plus y equals 10 was the blue, and then the x minus y equals 8 is the red. So that actually gives us our C intersection, not our B. So let's get rid of that. Make that C. Then, so now we got to switch it. We got to go back and do B. So B is coming from blue and purple. So blue is still x plus y equals 10, set. Purple is x minus y equals 8. Sorry, excuse me, negative 8. There we go. I'm sitting here thinking they're the same equation. X minus y equals negative 8. There we go. So now, again, you can solve this using reduced echelon form in the calculator. You can solve it using whatever, but I, again, just see it really easy. You just add, so that makes 2x equals 2, which means x equals 1. So now we back sub into either equation, so that gives me 1 plus y equals 10. So then we solve, that gives me y equals 9. So not surprisingly, because of the symmetry of the equations, we have a symmetry in our answers of 1, 9 and 9, 1. So now we have our 4 corner points, but we're not quite done. So now the question is, which one gives us the maximum value and which one gives us the minimum value? So for that, we need to go back and look at our problem to see what the equation we're trying to maximize and minimize. So here we see it's p equals x plus 2y. So I went ahead and wrote that right there. So now what we need to do is go through and substitute in our values into this equation. So the a value, which is 0, 8, we substitute that in, so it's going to give us p equals 0 plus 2 times 8, which gives us a p-value of 16. So then now we have to test b. B was the value of 1, 9, so when I substitute that in, that's going to give me p equals 1 plus 2 times 9, which is 19. So far, this is our max, that's our min, but that can all change. Now let's go to C. P equals, our C value was 9, 1, if you remember from up here. So 9, 1. So 9 plus 2 times 1, so that gives us a p-value of 11. So now, this value here, the 16, is somewhere, it's not a max nor a min, so we don't care about it. A is none of the above. So, but we still have one more value to check. We still have to check our D. So let's check D. What was the value for D? D was 8, 0. So when we substitute that in, that's going to give us 8 plus 2 times 0. So therefore now we have a p-value of 8. So again, we're looking for max and min. The highest p was 19, the lowest p was 8, so therefore C is out. So therefore we're going to have a max at B and a min at D. And so now we can go back and kind of put this all together. So what is our min at D? Well, we have a minimum of 8 at the point, what was D? 8, 0. And we have a max at B, that was a max of 19 at the point 1, 9. So now if we go back and look at the answers, hopefully we got it right. So you can see you have a max of 8 at 8, 0 and a max of 19 at 1, 9. So there's the problem from start to finish. I apologize about the little mix-up in the middle where my color blindness got me there, but I hope it still made sense when we got through it all. Let me know if that fixed whatever issue you were having.